So neonatal jaundice is an important topic because it affects so many babies. Around 60% will be jaundiced shortly after birth, and that number's even higher if you look at preterm babies. This is what a baby kind of looks like if they're jaundiced. There's a nice kind of golden colour. It looks like they've had a nice tan. And you don't really notice just how jaundiced they are until you actually look at the colour of normal skin in there. Now, jaundice can be quite upsetting for the parents because they think there might be a major problem with their baby. Of course, most times there isn't, but we do need to understand why jaundice is important, what diseases it can point to, how it can cause problems, and what we're going to do about those. Now, when you learn about jaundice, you often get faced with a diagram a bit like this, which is my kind of summary slide. We'll have that at the end as well, but it's quite difficult to work through. It's all to do, though, with the breakdown of red blood cells. So that's probably where we ought to start. So when blood cells get old, and they get old in the fetus, they get old in the baby, and they get old as you age as well, because they don't have that long a lifespan, there's so much good stuff inside the red blood cells, the body is very keen to recycle it. So this is my diagram of a hemoglobin with a heme ring and a piece of iron in the middle of it there. So when the body breaks down an old red cell, it wants to recycle this. So what it does is it takes out those globin subunits, and those globin subunits get broken down into amino acids. These can be then used to make more hemoglobin or perhaps some different sort of protein. The heme itself is broken down as well, and it gets broken down into its constituent iron. Iron, again, is a very important thing to have. It can get used in lots of different things, and so that gets recycled too. The bit that isn't recycled is the heme ring itself, which isn't very big, but is quite toxic. So let's have a look back at the heme ring, because the heme ring is the thing that's going to be driving the whole problem of jaundice. So heme itself is quite a toxic compound because it's very lipophilic, so it loves going into things that are fatty in the body, and there's lots of fat in the body, but particularly the cell membranes, because that's really how the body ticks, is with all these wonderful cell membranes that do all these very, very clever things controlling what happens in and out of the cell. And the heme, being quite lipophilic, would like to associate with this, and if it does so, it will damage the function of the cell. So heme is converted into something else called bilirubin, which is less lipophilic, and initially it's what's called unconjugated. And the conjugation is something we'll come back to, but while it's unconjugated, it remains quite lipophilic and could potentially still go into cell membranes. So what the body does is it converts it into something called conjugated bilirubin by adding some glucuronic acid elements to the bilirubin that are sort of stuck onto the side of it. And when it does this, it then becomes water soluble. This is very helpful because this can now be excreted, because when the body excretes something, it always excretes it in water, either in urine or in bile. And bilirubin comes out in bile, it goes then into the gut and into the stool. And this conjugation process happens in the liver, and there's a specific enzyme, it's called UGT for short, but that actually stands for UDP, glucuronosyl transferase. It's quite a mouthful, so we'll stick to UGT. Now, UGT is a rate-limiting enzyme, so if you don't have enough UGT, you don't get enough conjugation of the bilirubin. And this system is also quite easy to overload if there's too much coming down. For instance, if there's a big breakdown of red cells, and we see this in other conditions like, say, sickle disease, you can sometimes see it as well in massive hemorrhage that you might see elsewhere in the body. But around the time of birth, this is a particular problem. So once we've got this system, we need to think about why this is a particular problem for the neonate. Now, the neonate, as I said, also has cells that age. In fact, they age quite a bit faster than cells in the neonatal and infant and older humans as well. And they're also making this heme. And just as in older children and adults, it gets converted into unconjugated bilirubin. Now, this isn't such a bad thing in the fetus, because this unconjugated bilirubin, being fat soluble, can pass across the placenta and can then get processed in the maternal liver. In fact, if you think about it, it's a good idea to not conjugate it, because there's no way that a fetus can actually excrete a water-soluble substance, because it doesn't have urine that can be properly disposed of, nor is it making bile that can go out in stool because it's stuck inside the uterus. So going out through the maternal liver and getting conjugated there and going into mum's bile and her stool is a good idea. However, as soon as the infant is or the fetus is removed from the placenta and it becomes an infant or a neonate, it's now got a problem, because this system won't work. So what it has to do is turn on its UGT through its infant liver and start conjugating that bilirubin, and so it can excrete it. And delays in doing that are what leads to the issue of neonatal jaundice. So one type of jaundice we see is so-called physiological jaundice, which basically means that there's a slight delay in this process of UGT being turned on. Typically we see the jaundice appearing after 2 or 3 days, when there's enough bilirubin that's gone down this process to actually appear in the skin. And you have to get to a level of around 50 to 60 micromoles per litre of bilirubin for it to actually be seen, the pigment to be seen in the skin. Such physiological jaundice disappears by 14 days when the UGT is turned on to sufficient levels. It's quite mild and not particularly dangerous for the baby. So that's physiological jaundice. It's important to recognise how common that is, because it looks kind of the same as the other sorts of jaundice with subtle differences. There are 3 other types of jaundice which we need to focus on, because they're all proper disease states and can be very dangerous for the baby: hemolytic, intrahepatic and post-hepatic. And let's look at those in turn. So really what we're doing is we're going down that pathway, that degradation pathway, and there's problems along there. So first of all, hemolytic. Now, if in hemolytic, what's happening here is red blood cells are being broken down at too high a rate. And if they're being broken down at too high a rate, you're getting too much heme entering the system for the UGT to process. And then that can cause a very dangerous build-up of the bilirubin at the unconjugated stage. Then you might also see features coming from the hemolysis, so such as pallor. The baby may look pale. If you measured the hemoglobin, you'd actually find that it's low, and you might see damage to the red cells if you were to look under a microscope at that. And these are the common diseases that cause hemolytic. So these are all incompatibilities between the mother and the fetal blood. Okay, so this is antibodies going across the placenta from the mother to the fetus, and they do this because the mother may have a blood group such as, say, O, and the baby may have, or the fetus may have antigens such as A or B, and that reacts, and the mother reacts against those. Or the baby may be rhesus positive and the mum rhesus negative, and again that rhesus antigen activates the mother's immune system, causing antibodies to cross the placenta. So that's hemolytic jaundice in there, and can be very dangerous, both causing the anemia and can also damage with very high jaundice levels. The intrahepatic is where the slow processing of normal amounts of bilirubin coming down the tree or down the pathway. And if you were to look more closely at the liver function, you might find, like, say, liver enzymes are deranged. Sometimes this is caused by infection, which slows down the processing of the liver. But 2 other things can be important as well: hypothyroidism and so-called breast milk jaundice. So breast milk, there's something in it slows down the function of UGT. We don't know what it is. Again, a very benign disorder, but it does cause a prolonged jaundice. And the other important one there is hypothyroidism, because the thyroid hormone is important in maintaining normal metabolism, and lack of it slows down the function of the liver. So those are the 2 ones that give you unconjugated jaundice. Once the bilirubin has been conjugated, it then needs to get excreted in the bile, and if there's a problem there, you end up with an obstructive jaundice. So just as in an adult, you'll see pale stools and dark urine. If you measure the blood, the jaundice is conjugated, and the most common condition causing this is biliary atresia, congenital absence of the bile ducts. So if you manage a patient with jaundice, the first thing to do is to ask some questions and examine the baby properly. If the baby has a hemolytic jaundice, you might find that there are previous babies who've had problems with jaundice. Check the mum's blood group and see if it could cause a hemolytic type of problem. The Mediterranean background is important because G6PD, glucose 6-phosphate deficiency, is much more common in people of Mediterranean origin. And lastly, the timing is very important because this jaundice appears fast. So if jaundice is coming in the first 24 hours, that is abnormal and it's probably hemolytic in origin. The intrahepatic type is you may find features of maternal infections, particularly viral infections, which can cause a hepatitis in the fetus. Or you may see features of floppiness, poor feeding, which might indicate the baby has sepsis. Or you might find some features of hypothyroidism, such as a large tongue or enlarged anterior fontanelle. The posthepatic one, again, fairly straightforward. Check the stool colour and the urine colour to see if there are features of blockage at this system. So why is jaundice a problem? So we've indicated some fairly serious underlying problems, but the other issue, of course, is toxicity. And toxicity from the bilirubin itself can be very, very dangerous because unconjugated bilirubin can enter the brain cells and that will cause damage. And the type of damage is called a condition called kernicterus. Okay, and kernicterus happens when this bilirubin enters specific bits of the brain, and particularly the basal ganglia seem to be affected. And that's what you can see on the right-hand side there, a section of a brain from a premature baby who died, but you can see the yellow staining right inside the brain. Outside, this is what the baby may look like with what's called opisthotonus, so extensor posturing. The baby may also be very floppy and disinterested in feeding. And this baby is going to go on to have long-term cerebral palsy, and that could be completely avoidable. So how do we avoid it? Well, there's two main ways we avoid it, using phototherapy and an exchange blood transfusion. Let's have a look at phototherapy first. So phototherapy uses a specific blue-green light to change the unconjugated bilirubin in the skin to some water-soluble isomers that can then get excreted and removed from the body. It's not actually conjugating it, but it is making it usable so that the liver can get rid of that. You obviously need a lot of skin exposed for that, so just a nappy on, and the more light that can go on, the better. So what you'll see is a baby. This is a picture taken of a serum sample of a child with some high bilirubin, and if you leave it in the sunshine, it actually all clears in that sort of way. And this is what a baby looks like under phototherapy. So it looks quite a sort of ghostly light, and you have to shield the eyes from that. You can also have a blanket that goes over the baby that has light in it, or a mat, again with the same wavelength light underneath that the baby lies on. And that's all very effective at reducing the bilirubin over hours to days. Now, if things are very, very bad and the level's very high or going up very quickly, we need to do an exchange blood transfusion. And for this, we'll take some group O rhesus negative blood and give that to the baby in small aliquots, and at the same time remove the same volume of the baby's own blood so the baby doesn't become fluid overloaded, and discard that blood because that blood will have a high bilirubin level and will also have potentially some blood that's antibodies are reacting against. So that's a very quick tour of neonatal jaundice and its issues and how you deal with it. Here is the summary diagram, which I also hope is helpful for you. Thank you.